Hello students, welcome. In this video we will discuss Gauss theorem. So first of all, let us discuss area vector. So you all know area is a scalar quantity. For example, if you are having this rectangular surface, so area of this rectangular plane is what? Length into breadth. This area is a scalar quantity. But what is area vector? So area vector is a vector drawn perpendicular to this area. If you are drawing any vector which is perpendicular to this area, this vector is termed as the area vector. So the definition of this will be a vector drawn perpendicular to area is called area vector. Now suppose this area vector we represent it like ds vector, and the direction of this area vector is given by unit vector n, and area of this rectangular plane, let it be ds. So you know unit vector is a vector divided by its magnitude. So ds vector over its magnitude is what? ds. So now area vector ds is equal to magnitude of vector ds into unit vector n. So in this way you will represent the area vector. Now we will discuss what is electric flux. Electric flux. We have already studied about the electric field lines. You know, electric field lines start from the positive charge and at the negative charge. Now suppose you are having area here like this one, and electric field lines are crossing the area normally. So what is electric flux? Electric flux से किनो कमांगे? Total number of electric lines of force crossing this area normally. Means उसे ਜਿਹੜੀਆਂ electric field lines इस area ਨੂੰ normally cross ਕਰਨਗੀਆਂ, ਅਸੀਂ ਉਹਨਾਂ ਨੂੰ ਕਿਆ call ਕਰਨਾ ਹੈਗਾ? Electric flux. So electric flux is what? Total number of electric field lines crossing the area normally is called electric flux. It is noted by phi. Denoted by phi. Now let us discuss it more. थोड़ा और ਇਹਦੇ ਬਾਰੇ डिस्कस करते हैं. ਕੀ ਕਿਹਾ ਕਿ ਆਪਾਂ ਜੋ ਏਰੀਆ ਤੁਹਾਡੇ ਕੋਲ ਹੈਗਾ ਉਹਦੇ ਵਿੱਚ ਕਿੰਨੀਆਂ ਇਲੈਕਟ੍ਰਿਕ ਲਾਈਨਸ ਆਫ ਫੋਰਸ ਨਾਰਮਲੀ ਕ੍ਰਾਸ ਕਰ ਰਹੀਆਂ, that is called the electric flux. Here two electric lines of force are crossing, so it means its electric flux will be 2. Now suppose you are having another area like this one, and here more number of electric field lines crossing. So we are seeing here only 2 electric field lines are crossing this area, and here these are 4 electric field lines are crossing. So now its electric flux is larger. The electric flux associated with this surface is larger than this surface. So it means your electric flux depending upon the electric field lines. Larger the electric field lines crossing through the area normally, larger the electric flux. Now suppose you are having another surface here like this one, and here only two electric field lines are crossing. Area is smaller. So only two electric field lines are crossing. So here electric flux will be smaller because area is much smaller. So it means electric flux is also depending upon but area. If area is small, electric flux will also be small. So if you combine these two equations, but you get phi directly proportional to EDS. Now remove this proportionality. So what we take? KEDS. So here SI system. In SI system we take K equal to 1. So phi equal to EDS. Also we will find another formula for electric flux. So for that, suppose you are having a surface like this one and its area of this surface we let S. Now suppose large number of electric field lines are crossing here like this one. So the direction of electric field you know already, positive to negative. Now suppose here a small area ds. This is the small area ds. Now if this is the small area, then it will have area vector. Area vector is what? A vector perpendicular to this area. So suppose this area here, and this is the vector which is perpendicular to the area and represented by ds. This is our electric field and this is what? Area vector. So ਅਸੀਂ ਕੀ ਦੇਖ ਰਹੇ ਹਾਂ ਕਿ area vector and electric field ਦੇ ਵਿੱਚ ਕੋਈ angle ਹੈਗਾ, and let angle between the electric field and area vector be theta. So what you have to write? Let a small area ds inside electric field such that area vector ds makes angle theta with electric field. Now if you resolve electric field, it will have two components. One will be the horizontal component along ds and other will be the vertical component. So the component along ds, that will be what? E cos theta. Here it is your electric field, right? So the component of electric field along area vector ds, that is E cos theta. Now what is electric flux? Electric flux is equal to the product of electric field into area. So electric field is what? E cos theta into ds. The formula for electric flux is what? EDS. What is electric field here? E cos theta. That is electric field along the area vector. So now phi equal to E ds cos of theta. As area associated with this electric field is small, so this will be small electric flux. So we will represent it by d phi. So you know the dot product A dot B. What is A dot B? Magnitude of A, magnitude of B into cosine of angle between them. So same is here. It is A B cos theta. So it can be represented as E dot ds. So now this is the small electric flux related with small area. Now if we have to find total electric flux, then we have to integrate. So phi equal to integral of EDS. It means electric flux is equal to surface integral of electric field. So this is the important formula for us. Now we will discuss Gauss theorem. Gauss theorem also gives us the electric flux. We have calculated electric flux through this formula also. Now what the Gauss theorem say? Suppose you are having a surface like this one and a charge Q lies inside this surface. So what the Gauss theorem say? Gauss theorem say the electric flux through this closed surface is equal to 1 upon epsilon 0 charge inside, whatever the charge inside this surface. So first of all, let us write the definition. The total electric flux through a closed surface is equal to 1 upon epsilon 0 times charge inside that surface. Mathematically, what it say? Total electric flux means phi equal to what? 1 upon epsilon 0 charge inside the surface. So means to say phi equal to 1 upon epsilon 0 into Q, or simply it is Q upon epsilon 0. So this is the Gauss theorem. Now let it be question number 2. Also from the definition of electric flux, but we calculated phi is equal to surface integral of electric field. So now from equation 1, phi equal to surface integral of electric field. So now equate these two equations, both are equal. This electric flux is through Gauss theorem and this electric flux through the definition. So what will we conclude? E dot ds is equal to Q upon epsilon 0. So this is the important conclusion we draw from here. And how will we write it? Surface integral of electric field through a closed surface is equal to 1 upon epsilon times charge inside the surface. So this is the modified Gauss theorem, you can say. Now let us take a quick revision. What it say? Gauss theorem. The total electric flux through a closed surface is equal to 1 upon epsilon 0 times charge inside the surface. Means if you have a surface and any charge lying inside this surface, so electric flux, it is very easy to calculate. What it say? Electric flux is equal to 1 upon epsilon 0 charge inside the surface. यानी जिन्ना भी चार्ज अंदर हैगा उन ਆਪਾਂ epsilon 0 ਦੇ ਨਾਲ डिवाइड करना है, ਸਾਡੇ ਕੋਲ क्या आएगा? इलेक्ट्रिक फ्लक्स आ जाएगा, right? So dear students, in this way We have discussed the Gauss theorem. In the next video, we will discuss proof of Gauss's theorem. So thank you very much.